guys, I'm here with you today to talk about exponential equations and how you can go about solving them. And then we're going to get into some logarithmic equations that you're also going to solve. You're going to kind of use the same skills. So, very important that you understand this, okay? So when you're looking at an exponential equation here, you have an expression on each side of the equation, and kind of makes sense in number one that if both of these bases are 25, then obviously these two parts can be dropped and you can set the two exponents equal to each other. I hope that makes sense to you. So if they have the same base, the exponents are equal if the equation is equal, okay? Because whatever value that is on the left side, it's the same exact value on the right side. So in this case, all you have to do is drop your bases. They're the same. Set the exponents equal to each other, and you know how to solve that. We're going to take 2x from each side. That's going to leave me 3x minus 9 equal to 3. I'm going to add 9 to the other side. It's going to leave me 12. I'm going to divide by 3, and x is equal to 4. And it's very easy to check these. You just clearly, you're just going to plug in for x right there. 2 times 4 is 8. 8 plus 3 is 11. On the other side, 5 times 4 is 20. 20 minus 9 is 11. And 25 to the 11th power equals 25 to the 11th power. Okay? All right, so that was pretty simple. Looking at number 2 right here, they don't have the same base. So you can't just drop the bases and set the exponents equal to each other. You really got to have the same base. Well, in this case, it's very easy for me to rewrite 81 so that it has a base of 9. 9 squared is 81. So that's easy to do. I'm just going to change 81 into 9 squared. Remember, if they're equivalent, they can replace each other. Okay? Now, I'm going to rewrite the rest of the equation. So all you're doing is rewriting 81 as 9 squared. So we're going to keep 3x plus 6 as the exponent there, but it's got a 2 next to it this time. And we also have 9 to the 8x minus 4 on the left. Okay? All right, now that we have the same base, you're able to drop those bases and set the exponents equal to each other. However, before you do that, I would go ahead and distribute. Remember, when two powers are side by side like that, the law says multiply. So we're going to have 8x minus 4 equal to 6x plus 12, okay? And then you're going to have an equation that you can solve. I'm going to subtract 6x from 8x and get 2x. I'm going to add 4 to 12 and get 16. Divide by 2, x is equal to 8. Okay, and again, you can plug that back in. 8 times 8 is 64. 64 minus 4 is 60. So you've got 9 to the 60th power. You can check that in your calculator. It's probably a really large number. And then 3 times 8 is 24. 24 plus 6 is 30. 30 times 2 is 60. So that would also be 9 to the 60th power. Okay? All right. Same thing with number 3. You could easily change 16 into 4 squared, and that would solve your problem there. So I'm going to move on to a problem where we need to change both bases. Okay? So if you look at number 4 right here, there is no way to rewrite 8 with a base of 4, meaning I cannot write 8 so that it has a base of 4. There is no power that will give me 8. And don't say 4 squared, because you know what 4 squared equals, 16, okay? So it's not 4 squared, it's not 4 to the first, okay, that doesn't equal 8. So what we can do is we can rewrite 8 with a base of 2. Now if 8 has a base of 2, it's going to have to be 2 cubed because it still has to equal 8, okay? You can also rewrite 4 with a base of 2. You see where I'm getting? So now we've rewritten both bases so that they have the same base, okay? You changed 4 into 2 squared, which is equal, and you changed 8 into 2 cubed, which is also equal. So now you're able to set those exponents equal to each other, and that's what you want to be able to do to solve the equation, okay? All right, so now we're able to drop those bases. We're going to go ahead and distribute real quick before we rewrite this. It's easier to go ahead and distribute there. We're going to have 6x minus 6 equal to 12x minus 12. We're just going to keep solving. We're going to minus the 6x from the 12x. We're going to get 6x. We're going to add 12 on the other side to 6. We're going to get positive 6. And we're going to divide by 6 and get x equal to 1. We're going to check that again, remember. We're going to plug the 1 in here. 3 times 1 is 3. 3 minus 3 is 0. Uh-oh, so I'm going to get 4 to the 0 power over here. All right, 4 times 1 up here is 4. 4 minus 4, again, 0. Uh-oh. But y'all, do y'all remember what anything to the 0 power equals? Anything to the 0 power is 1. So this is still true for x equals to 1 because 4 to the 0 power is 1, but so is 8 to the 0 power, okay? All right, so I'm going to do at least one more. Let's see. Let's try number 5 here. Okay, so you've got 9 and 27, all right? The first thing you may think of is, hey, maybe I can change 27 so that it has a base of 9. But when you try that, you know, you're going to probably say, that's too big. 9 squared can't be 9 squared. That's 81. That's not going to work. So you're not going to be able to change 27 into a base of 9. But what you can do is change 27 to a base of 3. Because 3 to the 3rd power is 27. And guess what you can do on the other side? You can also change 9 into a base of 3. 3 squared is 9. So once you do that, you're able to just keep going like you were doing before, setting them equal to each other. There you go. Distribute. You can drop those bases now. We're going to have a negative 2x. Positive 10. We're going to have an 18x minus 30. And we're just going to keep going from there. We're going to add 2x to the 18x, which is going to give me 20x. I'm going to add 30 to 10, which is going to give me 40. Divide by 20 and get 2. Okay? And let's check that again just to make sure, okay? Negative 2 plus 5 is 3, so we're going to get 9 to the 3rd power over there. And over here, we're going to get 12 minus 10, which is 2. And looks like that would work to me. Yep, that would be the same number. 27 to the 2nd power, 729, and 9 to the 3rd power, 729. So very good, okay? So be sure to check those answers as you work and let me know if you have any questions on that. Okay, so now that we have talked a little bit about exponential equations, I do want to get back into logarithms. I know I covered this a little bit with you at school. And why are we going straight from exponential to logarithms? Well, if you remember from school, we talked about how logarithms, they're just another way to write an exponential equation. And so they're closely related. And they mean the same thing a lot of times. So like number 1, if you'll recall, we say log base 3 of 243 is 5. And if y'all remember, we said log is bay. So we say log is bay. So that means we've got the base, the answer, and the exponent. Okay, so if you guys can remember that, that'll help you so much. Okay, right now, I'm just keeping it really easy with these. We're just going to set, and we're just going to change these to exponential form. So keeping in mind that log is bay, our base in number 1 is 3. Our exponent is 5. And our answer is 243. Base, exponent, answer. Base, exponent, answer. I'm just placing the right numbers where they go, okay? Is that true? Is 3 to the 5th 243? It sure is, okay? So it should make sense to you when you rewrite it. Over here, we've got log is base, so base is 4, exponent is 3, Answer is 64. Over here, we've got base is 9. Exponent is 1/2. If you recall, what does that mean? Square root is 3. Very good. Base is 5. Exponent is -2. Remember, a negative exponent means you flip it. Is that true then? Sure is. Okay, so it's very easy for you guys to change your exponential or your logarithm equation into an exponential equation. Okay, we're just going to do the same thing on the bottom, but we're going to transform it into a logarithm. So again, keeping in mind that log is base, we're going to say log base 2 because that's the base. Answer is 8. Exponent BAE. Remember BAE, and the exponent is 3. So you're always going to equal your exponent there. Okay. Okay, log is base, so log base 3 of 9 is 2. Log base 8 of 1/64 is -2. Log base 1/3. I should have made that smaller. Sorry. Log base 1/3 of 1/9 is 2. Okay? All right. Okay, and then the last thing that we're going to talk about is just how to evaluate, which we also discussed in class, but I wanted to go over it with you again. When someone tells you to evaluate, that means they want you to get a value, okay? And so what is it that we're missing here? We have log is base, remember? So we have the base and we have the answer. So what we're actually missing is the exponent, okay? So you just need to figure it out. And you can set up, just like we did a minute ago, you can set up an exponential equation, okay? So for instance, if you want to set this up as an equation, you don't have to do it this way. You can just tell me what the answer is because I know most of you know, okay? But if you need an equation, you could always change the log back into exponential form, okay? So we don't know what the exponent is. We're going to call it x, okay? So if we use the base, the exponent equal to 25, we're able to say, oh, okay, I can change 25 so that it has a base of 5. So I can rewrite 25 as 5 squared. And we just did earlier, if they have the same base, you can drop them and you have your equation here. So x is equal to 2 in that case. I know you probably could tell that by looking, but they do get a little bit harder later on and you may need an equation, okay? Like this one. Here we go. 9 to some exponent is equal to 3. Okay, you might be like, what is that? I'm confused, okay? Well, you have your equation. Let's solve it, okay? In order to drop these bases and set up your equation, you have to have equal bases. And so right now we don't, but I can easily change 9 into 3 squared, right? If I change 9 into 3 squared, I still have an x there, remember? At that point, now we're able to, remember that's an understood 1, okay? We're able to drop those bases and say, okay, 2x must equal 1. Well, if 2x equals 1, then to solve, we've got to divide, and we end up with what? A fractional exponent, which makes sense in this case. Because if you're going to, from a bigger base to a smaller base, obviously something drastic had to happen, right? That exponent had to be a fraction. So you actually took the square root of 9, and that's true. It is 3, okay? So you see how these exponential equations can help you? Let's do a few more. Remember, and I don't know if you caught this, but they may not put that base there. So if you're missing a base in your logarithm, it's understood to be 10. Okay, guys? That one's pretty easy. Let me try to find one. That one's easy. Let's do a fractional problem. Okay, so again, set it equal to x, okay? That'll help you. All right, so we're going to switch this into exponential form, okay? 4 to some exponent is equal to 1/64, okay? Now, I'm not telling you you have to work it all out. You might look at it and tell me, okay, I know what that is, okay? But if you need an equation, use it, okay? All right, so I can rewrite this with a base of 4, okay? 4 to the third power is 64, right? Well, we don't want it to be 64. We want it to be 1 over 64. So I'm actually going to write it as 4 to the negative third power, okay? That's all you have to do if you want to, use a base of 4. To make it a fraction, it would just need a negative exponent, okay? So that's true. 4 to the negative third is 1 over 64. So now you have those like bases, and you're able to drop them, and your result is negative 3, okay? So I really want to see y'all try to work these out. If they're easy, you guys can just answer them, straight off. But, when they get a little bit harder, I do expect to see some work, okay? And I want to talk to you a little bit more about how I'm going to grade your work for this semester. So I will do a separate video on that, okay? But just keep trying hard. I know you guys are disappointed, some of you, okay, about the announcement today that we'll no longer be physically going to school, but that doesn't mean we stop learning. It's just going to be more up to you that you stay on track, okay? So I'm going to give you lots of practice on what we learned, and I expect you guys to do your best. Hit me up if you have any questions. Don't give up, because this is your future, and, I'm going to be here to help you. If you want to get ahead, I understand that too. There's nothing that says you can't get ahead, and I'll go ahead and give you the rest of the year's calendar if you want to do that, okay? I feel like if we work hard, that we can stay on track, and there's nothing that you can't do if you put your mind to it, okay? All right, guys, finish up this week's work, and then we'll have some more next week. I'm going to just plan on doing it week by week so that you don't get overwhelmed, okay? All right.